by 2050. Restoring our oceans isn't just an option, it's an absolute necessity. For decades, the relentless pressures of pollution, overfishing, and climate change have pushed marine ecosystems to the brink, leaving them fragile and in decline. But now we stand at a pivotal moment. Technology has gifted us a new arsenal of tools, empowering us to actively restore habitats, rebuild biodiversity, and stabilize our coastlines for the future. Coral reefs, often called the rainforests of the sea, are among the most beautiful and vulnerable ecosystems on Earth. But technology offers new hope. Using advanced 3D printing, scientists can now create intricate frameworks that mimic natural coral structures. These artificial scaffolds accelerate reef growth and provide a stable foundation for new life to take hold. In parallel, specialized coral nurseries are cultivating resilient, heat-tolerant species. Once mature, these supercorals are carefully transplanted back onto damaged reefs. To scale these efforts globally, robotic planting devices are deployed, ensuring precise placement with minimal disruption to the delicate environment. This powerful combination of engineering and biology is enabling reefs to recover at a pace that nature, alone, simply cannot match. Beyond the reefs, seagrass meadows and mangrove forests stand as silent guardians of our coasts. They are vital powerhouses for carbon sequestration, serve as critical nurseries for countless fish species, and act as natural barriers against storms. To bring these habitats back, we're deploying AI-guided drones that plant seeds with incredible precision, targeting the exact locations where they have the best chance of survival. Meanwhile, from high above, remote sensing satellites monitor their growth and track environmental conditions in real time. By restoring these natural buffers, we not only protect our coastlines, but also enhance marine productivity, boosting both climate resilience and overall ecosystem health. The damage isn't just on the surface. Decades of human activity have left vast stretches of the ocean floor barren, hindering biodiversity and crippling fisheries. To address this, we're sending in the robots. Autonomous underwater vehicles, or AUVs, are now tasked with the massive job of clearing debris, removing lost fishing gear, so-called ghost nets, and industrial waste. Once the seafloor is clean, these same AUVs can deploy modular artificial reef structures, creating new, complex habitats for bottom-dwelling species to colonize. Continuous monitoring systems then track sediment stability and the return of marine life, helping us evaluate our progress. Through this systematic, tech-driven approach, we are slowly but surely restoring balance to these forgotten underwater worlds. But what about the invisible threat? Chemical pollutants and microplastics contaminate vast areas of our oceans. Here, bioremediation offers a groundbreaking solution, using nature's own processes supercharged by science to detoxify the water. Scientists are engineering specialized microbes and enzymes designed to break down specific pollutants like oil, plastics, and harmful chemicals into harmless substances. When these treatments are combined with physical habitat restoration, they dramatically improve water quality and create a healthier environment for species to recover through continuous research and careful, controlled application. We can ensure these methods are not only highly effective, but also completely safe for the surrounding ecosystem. Restoring our oceans requires thinking outside the box, or, in this case, beyond the coastline. For open water areas where direct human access is difficult, we are deploying incredible floating restoration platforms. These autonomous solar-powered systems are designed to plant and cultivate vast underwater forests of kelp and seaweed. These fast-growing marine plants are champions of carbon capture and help locally reduce ocean acidification, all while providing food and shelter for marine life. Other platforms are equipped to establish oyster beds, with each oyster filtering gallons of water a day, dramatically improving clarity and rebuilding benthic communities. Guided by AI, these mobile systems constantly monitor environmental conditions, optimizing growth and survival rates, effectively extending our restoration capabilities far into the open ocean. How do we know if any of this is actually working? That's where global monitoring and artificial intelligence come in. A network of satellites, sensors, and drones gathers a constant stream of data from restoration sites around the world. This information is fed into powerful machine learning models that can predict ecosystem recovery trajectories and identify which strategies are most effective. Interactive dashboards allow scientists and policymakers to track key performance indicators like biodiversity recovery and pollution reduction in real time. This data-driven approach allows for unprecedented international collaboration, as nations can share datasets and best practices to scale efforts globally. Restoration becomes measurable, efficient, and adaptive, ensuring every investment yields the maximum ecological return, and that our success is validated by science. So, what does the ocean of 2050 look like? If we commit to a coordinated global application of these technologies, the future is bright. Imagine millions of hectares of degraded ocean habitats brought back to life. Picture thriving coral reefs teeming with color, vast mangrove and kelp forests swaying in the currents, and crystal-clear waters supporting resilient fisheries and stable coastlines. Technology is not meant to replace nature, but to amplify its incredible power of recovery. It makes the dream of large-scale ecological rehabilitation not just a possibility, but a tangible, sustainable reality within our reach. The journey to restore our oceans is a race against time. The challenges are immense, but so is our capacity for innovation. With strategic application of technology, unwavering commitment, and global cooperation, we have the power to heal our blue planet. We can rebuild the seas, ensuring a healthy, thriving ocean for all future generations.